Hey guys, today's video is going to focus on graph theory. Specifically, we're going to start what's called Euler paths and circuits, something totally new that you've never seen before. We're going to talk about a specific problem to intro this unit called the 7 bridges of Königsberg. So in Königsberg's Germany, a river ran through the city such that in the center was an island, and after passing the island, the river broke into two different parts, and thus 7 bridges were built so that the people could get to one part to another. I'm going to show you a picture of what this diagram looks like. So here's the little island in the middle, and you can see there's 7 bridges around going through the city. And here's the famous question of the bridges of Königsberg. Can you take a walk through the town, visiting each part of the town and crossing each bridge only once? For example, let me draw a little diagram here. Let's say we started here, and we're going to go across this bridge, and then this bridge, maybe this bridge around here. This is the path I'm taking, but I can't get, now I'm over here. I can't get back to that bridge because I can't pass through another bridge more than once. And I can't come back around here because there is no bridge. So the question is, can you come up with a path? Maybe you don't have to start over here. You can start maybe over here in the middle, in the island. Is there a path that you can take around these 7 bridges so you cross each bridge, but only once? Take some time to think about that. So in this problem, a resident of Königsberg wrote to Leonhard Euler, who's the famous mathematician, saying that a popular pastime for couples was to try to cross each of the 7 beautiful bridges in the city exactly once, without crossing any of the bridges more than once. It was believed that this problem was impossible to do. But why is it impossible? Could Euler explain the reason? We're going to use what's called graph theory to find out why it is impossible for this to happen. On the left here, we have a picture of Königsberg again, with the island in the middle, and some 1, 2, 3, 4, 5, 6, 7 different graphs. Euler realized that all the problems of this form could be represented by replacing areas of land by points, so like vertices. And the bridges will be like arcs, the edges. So here we have points of land, and then we're going to have our bridges. And at the bottom right here, here's another representation of what we're going to use for these bridges. So you could see that this middle bridge is from C to D right here. You can see that these 2 bridges at the top and bottom that connect D to B and D to A are right here and here. You can also see that these double bridges going from A to C are right here and here. And also you have from C to B, you have these double bridges, and that's what R and S are right here. Just another notation of how we're going to represent this graph theory. So Euler saw that there were 4 vertices, highlighted in red, and that each had an odd number of lines connected to it. He stated that there would either be the beginning or the end of his pencil path. And when I say even or odd number of lines connected to them, here's the vertice. So there's 1, 2, 3 lines connected to that vertex. There's 1, 2, 3 lines connected there, 1, 2, 3, 4, 5 here, and 1, 2, 3 there. Let's talk about how to identify graphs. So a graph is a data structure that consists of a set of vertices and a set of edges that relate to the verticesto of each other. Just like in a coordinate plane where you have an x and a y coordinate, in these graphs we're going to have an x and y coordinate, but they're going to be like the x is going to be the number of vertices there are, and the y is going to be like the number of edges there are. The degree is the number of edges coming from a vertex. So here are examples of vertices, and all the lines are edges. This vertex has a degree of 3 because there are 3 lines coming from it. This vertex has a degree of 2 because there are 2 lines stemming from that. How can this graph be denoted? Remember, we denote graphs through vertices and edges. How many vertices are there? 1, 2, 3, 4, 5, 6, 7. And how many edges are there? 9. What we're also going to do is label all the vertices and all the edges. So a better way to denote this graph would be to say the vertices, which are V, and I'm going to put them in set notation. A, B, C, D, E, F, and G are all the vertices, squiggly bracket. And then I'm also going to write what the edges are, and that's denoted by what E is. And all the edges also in set notation, squiggly brackets. Let me make that one a little bit better. And you're going to write down basically the path that all the tick marks went through. So we have a B to E. You write that as B, comma E. We also have an E to G. We have an F to G. And it doesn't matter if you do GF or FG. We also have an FD. We have a DE. We have an AB. We have an AD. Running out of room here. 2 more. We have a CA and also a CF. And in total, there were 9 edges that we had to count. And 1, 2, 3, 4, 5, 6, 7 vertices. This is how we denote graphs, by counting the edges and labeling the edges and also the vertices.